You need me to stop so you can write down the information, please let me know because I tend to go fast. So now it's fruit punch. This is good. I'm gonna see it anyway, Caleb. Sit down. Alright, so here we go. Bivariate data. Whenever we're looking, we have two variables. And realistically, we don't always look at one thing. We're always looking at two different ones. That's what bullet 1 is saying. And we're trying to find out how one relates to the other, which is bullet 2, and how it is that one of them is affecting the other. Usually you guys have heard, right, in science, oh, there's cause, effect, cause, effect, cause, effect. We don't ever really say there's a cause, effect. It's kind of hard to prove that. But we say, there's definitely one kind of, influencing the other, which is what the third bullet is saying. Now, here's the important things, the important words that you need to know from this one. And I'm going to use the this bad boy because I don't like the way this one writes. It doesn't let me use all my colors. So, okay. Now, here's the two important words that you need to get from this slide. One is the explanatory variable, and the other is going to be the response variable. Okay? So when we're talking about bivariate data, and we're talking about how one is affecting the other, you always want to think in terms of explanatory variable and response variable. Explanatory variable or response variable. Sure. That's what matters the most right here. I mean, the other stuff is just information. We're looking at two variables. That's what bivariate means. Okay, you don't have to write everything down word for word. I'll kind of point out what the important stuff is. Black, you got your ID? And if it bothers you when you're sitting at your desk, you can put it in the corner of your desk and then put it on the way out. Okay. Alright, cool. Can I move on then? No. Okay, I can wait too. Swah! It should be doobie.
What did you say?
That should be doobie. You never watched the noticias in the morning? We had the...
El Despierta América?
Yeah.
Yeah, like a lot of times.
That's what her last name reminds me of. Because she goes, what's her last name? That should be doobie. You remember how I used to do that all the time? Like, swah! No? Okay, I'm going to shut up. Yeah, that was a long time ago. They took them off. I was sad.
You guys talking about telenovelas?
Oh, no. Maybe.
You're trying to say that you're old.
I am old.
How old are you?
28.
Adam is my cousin. Old.
Adam is
Your brother.
Yeah. And he was my sister-in-law.
He's like 60.
Adam and Eve? Hello? Okay. What's the other one? Jesus is in my yearbook. My social security number is 2.
So, how old are you when you get graduated? Like, how old are you how old are you when you was done with high school?
Whenever you graduate. Yeah, there's a lot of
Yeah,
stuff
so I
that
think I
goes
was the same word, so I was trying to.
I was 20 years younger than I was 5 years ago. I'm just messing with you. That's not even true. 17.
What year did you graduate?
Now you're gonna make me think. 97. Yeah, 97. All right, cool. So I'm gonna move on. Yes. Okay. So explanatory variable. That's gonna be the one that explains what's going on with the observed outcome. So explanatory variable is going to be the one that explains what's going on. Let me try to make this a little bit easier for you guys. Well, actually, let me get to the other variable, and then you guys are going to be able to make a connection between those two. So the explanatory variable is the one that explains what's going on.
Wait, you said 1997 you graduated? So you graduated 36.
Dang, when you say it like that. Yeah. That's what you do.
No, I don't know.
Luis, si digo que estás chocho, ¿qué estoy diciendo?
Sí, no.
¿Ves? You sabe?
Yeah.
Thank you.
Yeah, because you said you repeated it so many times already.
Well, I said it one time.
The other day you said it too.
Oh, I didn't know. My bad. I just remembered because you were like, you thought we were.
You do.
We're like fighting the river this year. All right, cool. Here's the response variable. The response is going to be a measure of the outcome of the study. So how is this responding to the explanatory variable? Okay? And hopefully this should make sense to you. I think you guys have heard of these before, but in different names. Okay? So when we talk about the explanatory, we also talk about the response. Whoa, that was totally wrong. The response, we've called these the independent. What's the other name for this one? When we said something was independent, we said the other one was dependent. Okay, I think you guys are going to start making some connections here. What are some other names for the explanatory variable? Independent, we would call this domain. Ah. The easiest ones to remember. The what? The X and the Y. And that's really ultimately what we're looking at, is we're looking at two variables. We're looking at X and we're looking at Y. And most of the time as we're looking at how one affects the other. Now if you want to think about which one's which one is the X, people? The explanatory variable is the X. That's how I remember. And then the response is the Y. Okay? It responds to something. What is it responding to? X, the explanatory variable. Okay? Questions on that? Awesome. Sweet. Oops. Okay, so here's an example. Let's take a look at a couple of these and see if you guys can identify the explanatory variable and the response variable. No, let's just do these together. Don't write them down. They're just examples, okay? It would take too long. You guys would not be in here with me. So, if you have a study and they're looking at smoking and lung cancer. Smoking and lung cancer. Can you identify an explanatory variable and or response if there is any? Elises, what do you got? Which one? Which one is the response? Remember, here's the study right here. In the first bullet is what we're looking at. Can you identify in that a response variable and an explanatory variable? Are there any? What do you got? Beautiful. Exactly, right? Exactly. Do you smoke because you have lung cancer? No, you get lung cancer because you smoke. So this would be your explanatory. It's explaining what's going on, isn't it? What is going on? You're smoking, bro. What's responding? Oh, you're getting lung cancer. Make sense? So there's a good way of, there's an example for you. Let's take a look at another one. How about a study that looks at cavities and milk drinking? Is there even a relationship here?
Yes. The sugar.
There is, huh? Milk has sugar in it. It's called lactose. Lactose is a sugar made up of sucrose and glucose. And some other close. I love milk though, but I can't handle it.
Yeah, I'm like,
It hurts. Like,
I just do.
I guess your body gets used to not having milk, so it doesn't have to break it down. I didn't know that.
I do. I drink it anyways, but man, it's terrible.
It's a bomb.
Yeah.
Now I'm weird though. I like to put ice in my milk.
Oh, that's weird. You're weird. My
Because I like
sister
it
does
ice
that.
cold. Like, I like my milk cold, cold, cold.
My sister puts.
It just doesn't get cold enough, so I throw some ice cubes in there. Just bomb. Anyways, any relationship here? Drinking milk and cavities. Shay, what do you think?
Wait, what?
Explanatory variable, response variable? Good. Absolutely. So drinking milk causes cavities. And actually they did a study on that. That's why they say don't give babies their milk bottle in the crib anymore.
Why?
Because all the sugar's jacking up the teeth as they're coming out. And they come out all yuck mouth. And so they say don't give babies milk in the crib anymore. That's what's happening. The sugar stays there and eats up all their gums and nasty teeth and
So then where are you supposed to give them the,
water.
like you said?
Babies hate water though.
Yeah, you know how sometimes they do it so they go to sleep?
Water makes babies cry.
Well, usually when you put them in the crib, it's to sleep. I see what you're saying. Yeah, so if they're gonna go to sleep, don't put them to sleep with the.
But what happens
That was
if they
good.
put water with that powder?
It's the same thing. It's got sugar and it's got glucose. Come
Why
on.
do the doctors say not to give babies water? Why do you think?
They don't say that.
If you give the babies water, they cry.
At first,
Because water.
when they're babies, they need to have milk. They need the nutrients. Water doesn't have any nutrients. So, I mean, once they get a little bit older, then they're like, give them water.
My mom makes them with the food, like, ándale, se está muriendo por agua, está
They get the water from the milk. It's got whey in there and stuff, so it'll work. I know.
Wait, what did your grandma say again?
My mom.
What did your mom say? No, I'm just kidding. I can understand it. She I just messed up.
You just want to hear it again, huh?
Yeah, it sounded tight.
That sounds tight.
It sounded like she was in trouble.
What?
You're Mexican, you're always in trouble.
Oh, okay, thanks for that. Let's take a look at the next one here.
I thought that
A
was
study looks at rainfall and SAT scores,
What?
which is response, which is explanatory.
The explanatory would be rainfall, SAT scores would be the response.
So because it rains more, you do better.
No, it's worse. You could do worse because it was a bad day. It was raining outside. I got wet. I had to come in and take my SATs.
That makes sense, though, doesn't it? You guys ever, even me, when it starts to rain outside, like I really don't want to be teaching. I just want to be at home under the sheets, playing some Nintendo or something, and drinking chocolate and not being here. But so I guess that could be legit, right? But realistically, what would we say? Realistically, what should we say?
No relation.
There's no relationship here. That don't even make
Oh,
sense.
I thought you
man.
had to like make a relation.
If you did have to, that's why it says if any.
Yeah.
But I mean, yeah, I would say the rainfall would explain the poor SAT scores if they were poor. Cool. All right. So one way that we take a look at if there's any relationship between the two is that we take a look at the scatter plot. Okay, and a scatter plot's a good way of seeing the relationship between. Very important here. Make sure that you jot this down in your notes. It's a relationship between two quantitative variables. Okay, you can't do scatter plots with qualitative variables. They've got to be quantitative in nature. If you've got qualitative variables, then don't even think about doing this.
Wait, do we only write down the
Well, that's the important thing right there, okay? And also make sure that you put this. What you think is the explanatory variable goes on the x-axis. And that should make sense because x with explanatory, okay? It's always a good way of looking at it. Right, Black?
No, it sounds like a dog. True.
The car?
Oh, black.
I call mine the mini exploradora.
What is black in Mexico in Spanish?
Excuse me?
That was good. I take offense.
So it'd be like negro.
Victoria Negra. Right?
Alright.
You know what I call you? You know what I'm calling you? That's a hate crime.
Calm down, goddamn.
Hey, you know I used to tell the subs that was my name.
That wasn't your name?
That was my name. Like, I'd be like, it's pronounced Caleb. Just to be funny. Like, it's dumb.
Caleb. Caleb Hendricks. Hendricks.
My last name is actually pretty cool. Famous people got that last name.
There's only one that I like.
There's two though. So,
Shaw. Shaw. Cool. Questions here? Cool. Went the wrong way. Okay, so attributes. When you are doing a scatter plot, make sure that you have a consistent. It's just like the last one we talked about the charts. Make sure that you have consistent scale. Label both the x and the y so we know what you're talking about. What are the two variables? Make sure that you place your data correctly. And for that, you're really going to want to get your hands on some of this graph paper. It just kind of helps out with all that placement and stuff. Because I know I'm like horrible. If I try to do it on white paper, it's not going to work. Okay, moving on. And of course, you guys have seen scatter plots. Okay? They look like this. Notice you've got scaling on both sides. It's consistent. I've labeled both of them. And of course, I've placed all the values correctly. So I can take a look at if I've got a percentage that graduates at 10, I can come up and take a look at what their SAT score was. I should have put rain down here. That would have been funny. Amount of rain. Okay, cool. So, let's get to the nitty-gritty. When you have a scatter plot like this, there's only 3 things that you can say from this. So, we're trying to interpret the scatter plot, and there's only 3 things that you can do. One is the strength. Write that down. One thing is the strength. And when we talk about the strength, we're talking about how close are those dots. How close are all those different points? Are they spread out, or are they in a nice straight line? Okay, so those 3 things, that's all we can talk about. Well, we haven't said 3, one of them. Strength. The other thing is the direction. Okay, you guys remember slopes, right? Positive, negative slope. That's your direction. In this case, if we try to put a line through this, what direction would it be going in? The negative direction. So, strength, direction. Strength and direction are 2 of them so far. The last one is called form. Actually, I should just go ahead and show you the slide. Okay, so strength, direction, and form. And the form is pretty much like what shape is it taking on. Okay? If you look at the last scatter plot, they look like they're following a line, but sometimes they don't always behave that way. Maybe they're kind of curvy a little bit, so you would say, maybe it looks parabolic or quadratic in nature, or maybe it's exponential. So those are the 3 things. I'll pause here for a minute. You guys can write that down. Strength, direction, form. I'll have some more of this red stuff. John, are you thirsty? No. Okay. Wrestlers, 2 p.m. Oh, there you are. I couldn't see your name. I thought you were wrestling. Where do you guys do this one? The small gym? Yeah. Or the big one? They bring the mats out? Oh. 4-way match. Of course. So 2 o'clock, just got the email. You guys know? Okay, cool? No. Are you just tearing your pants?
no, there's like a string on my
You're supposed to use scissors. because if you yank it, you can start tearing out more and make it bigger. What the heck was that?
I don't know. That's my okay face.
Like someone get this dude some water.
No, that's what my dad. That's what my dad does. Like if I just say something to him, he's just like.
I love it. That's good. That's funny. Man, I try to do something like that, I could probably get 5. Why aren't you going to go to practice?
Because she just cried.
Oh.
No, my hand hurts. See, everyone
You guys eat?
I don't think I'm gonna go
Okay.
either. No, I do wrestling.
Also,
I like it.
one more thing, and thank you. So one more thing, and it's more about just not really interpreting, but mentioning, is are there any deviations from the pattern? Okay. Now in this case, because there's 2 different variables, what's interesting is you can actually have 2 types of deviations. Okay. Usually when we had bivariate, we just looked at whether it was way out on the left or it was way out on the right. Correct? Here, we can have a couple different things. So let's say I did have a chart, and I've got all these points, right? So let's say this was my data, and turns out maybe I've got one over there. You guys see it over here, the little green dot? That's an outlier, isn't it? Okay. Even though it follows the pattern of all the data, it's out here by itself. So make sure that you comment on something like that. Or maybe you have that, and you got a point out here. Okay. That's also an outlier because it's not with everybody else. Now, here's the difference between these 2. Point number 1 is an outlier. But is it really going to affect the overall pattern that we're looking at here? No, it still follows that linear path, doesn't it? But point number 2 is an outlier. Is that going to change the path of my line? Yeah, because what's going to happen when we're trying to create that line in here, it's going to have to shift up to accommodate for that. So this guy is called an influential point. Okay? The other's an outlier, but it's not that influential. The one that's definitely outside of that body is going to be an influential point. It's going to change the whole trajectory of the line to accommodate. So much vocab.
So there's like 2 outliers.
It's 2 types of outliers.
Or one's just influential.
Yeah, and this one's influential. Because remember, do you remember when we used to do the line of best fit? You ever did that in elementary school when you had like, oh, try to get half the dots above the line, half the dots below?
Yeah.
That whole idea? Well, we're going to kind of do the same thing. So if you have a line here it's fine, right? Like it doesn't really affect it.
Yeah.
But if I want to get that point in there, this line can have to shift, isn't it?
Yeah.
So you see how it's influential here? I don't have to move my line. But if that point comes into play, then this is going to shift. That's going to give me a whole different line.
You have 1 and 2 influential points.
That yeah, it can happen. It can happen. Data in real life is not nice. I mean, we don't get nice whole numbers like we do in math class. Oh, what's the answer? 5. No, in real life you get really horrible numbers. Like the square root of -1 comes up a lot. Okay? Or exponential notation. So, the only time you really get nice numbers is at school. And so we can learn the concepts. Okay? Questions on this this outliers portion? Cool beans. What? Wait. Go back. What did I do? Come back to me. Okay, cool. Alright, cool beans. Stuff this before it keeps going.